Okay, so again, let's play with this diagonalizable thing. So if A has n linearly independent eigenvectors, that's another way of saying A is diagonalizable. So that means PDP inverse is can happen. Okay, so I want to show in the end, right? I want to be able to show A transpose is equal to PDP inverse, right? And that's what I'm trying to show. All right. So having n linearly independent eigenvectors means that A is diagonalizable. So let's take the transpose of both sides this time. It's kind of similar to what I did in the last one, only last time I took the inverse. So I'm taking the transpose. So transpose, you're switching the order as you're taking the transpose. So I get to this. Okay, so let's think about it. Because D is diagonal, isn't D equal to D transpose? It is. All right, so I'm just going to rewrite this. So that means A transpose is P inverse transposed D P transpose. Now I'm just going to take the time to switch the transpose and the inverse. That is a property. Okay. So I want to get to something like this, right? So what I'm going to do is I'm going to say let, and I'll just use the letter Q again, let Q equal P transposed inverse. Because I'm trying to get to here, right? So I'm just being clever. So A transpose will equal, so this is what I'm saying, let Q equal. This is D, and think about it. Isn't P transpose, if I take the inverse of both sides, isn't that Q inverse? Take inverse of both sides, this gives me Q inverse, that's P transpose. I've arrived. I've shown that A transpose is diagonalizable. Got different letters, but I've shown it to be QDQ inverse. All right, last one. So I've got a 4x4 matrix with 3 eigenvalues. So each one of these has at least one eigenvector. I know one of the eigenvalues is 2-dimensional. So this has 2 eigenvectors. So lambda is 3 is 2-dimensional. So I know that lambda 5 and -2 both have 1 eigenvector. Does that mean I can get 4? So yes, I have, therefore, I have 4 linearly independent eigenvectors to make my P. So therefore, A is PD, P inverse. A is diagonalizable.